Hello, my name is Drew Doling, and I'll be talking about viruses and its evolution. I'll start with the background and the history. There have been many outbreaks in history, like the bubonic plague, which kills thousands of people. One of the most serious cases was smallpox. Smallpox has been one of the worst plagues in history. It was worldwide, and it killed many people in wars and in everyday contact. It was the main cause of deaths, and were mostly so the main cause of deaths in wars was smallpox. Even though there has been many killing of shootings and everything else, um, when a person got exposed to it, they will die in weeks. It was very contagious. It was airborne, and on the bottom right picture, there's the symptoms of smallpox, normal symptoms. When a person, so there was a man named Edward Jenner. Edward Jenner, um, during his time, there was a disease called cowpox, and there's another disease called smallpox at the same time. It was similar to smallpox, but not as deadly. He took pus from a person, and then pus from a person with cowpox, and injected it in a child that was clean, had nothing, no diseases in him. After a couple of days, he saw the child got the cowpox symptoms, and he made the child be exposed to a person with smallpox. After a week, he didn't get symptoms, and he was fine. When he found out the discovery, he was considered one of the first person made this vaccine. Um, so it was the first vaccination of his time, and he was well known for it throughout history. Um, So virus mutates through person to person, and in being exposed through airborne or other things like that. Um, and one of the things that virus does is that it attaches itself to a cell membrane, and then it injects its own DNA through its attachment. So from here in the picture, there's the protein coat, a DNA or RNA, it could be either or, and it injects it through the core into the cell wall. There's viruses are usually categorized by DNA and RNA, double stranded or single stranded. DNA viruses, they have genetic coding, they have accurate replication, which results in slower mutation rates. They're more stable compared to RNA viruses. Examples are herpes virus, hepatitis and hepatitis B. Another one is RNA virus. Same thing, usually single-stranded. Genetic material is RNA, usually more unstable. Does not contain certain proteins, which that is less accurate translation or replication. Just like influenza, Zika, West Nile River virus. The cause mutations, there are two cause mutations: antigenic drift and antigenic shift. Drift is it's a lesser foreign mutation. It causes viruses not to be inhibited by previous virus strains. As you can see in the picture, it's circle before it gets into the body, and then kind of half crescent moon after it leaves the body. Um, it's very subtle mutations. It doesn't go crazy with mutation itself, so it won't really affect that much. And antigenic shift, there's larger changes. So there's three of them. Instead of the body, when they come out, it's all three colors, totally different, just like HIV. That's basically what it means by HIV or influenza. It's very super hard to determine what's the cause of each virus, because based on the genome itself and the outside portion of the virus. We're going to talk about three viruses. One being the hantavirus. Hantavirus. So these viruses don't have vaccines for them right now. Hantavirus is a virus that came from rats and mice. Their hosts, they are usually transmitted through airborne, through fecal, and through just contact with so people in contact with the mice. It mutates through rodents, through rodent and person to person. So every time it gets sold to a person, it will change its genome, so that when we try to vaccinate for it, it is impossible for them to find the right source for the vaccination. Another one's HIV. It's contracted through sexual contact, body fluids, anything that has to do with blood, injections, or anything. A very high mutation rate. It's one of the highest mutation rates of any virus. It's considered to be it seemed to be super high to enough that we cannot tell any HIV virus if it's. I mean, we cannot vaccinate an HIV virus depending on its spikes or its genome. Um, attacks and it also attacks the central nervous system, so it attacks the T cells so that it cannot be harmed. Influenza, another one. So the last one, it has spikes that changes and it captures some of the spikes from the host membrane. Influenza is the same thing as the flu. It is also has high level antigenic drift, which causes the need of new vaccine every year. So we have different strains of influenza, namely H1N1, H5N5, and I think it's H5N1. Excuse me if I'm wrong. What the H's and N means are in this picture is hemagglutinin. It's a type of hemagglutinin, so like H5 would be a different type of hemagglutinin, and N, whatever number would be a different type of neuraminidase. So there's all the attachment. So they just classify every influenza virus by the classification of the spikes of the influenza. It spreads quickly through pigs, humans, and birds. So every year there's, like I said, there's new vaccine. So lastly, there's been cases that people have not been doing their vaccines, but vaccines are so important because the fact that they prevent the virus from passing from person to person, mutating. So if we stop this process of any virus, we're able to not have the virus become an epidemic, pandemic, or an outbreak, so that we're able to stop the source right there and there. Unfortunately, there has been a decline of vaccine usage, which causes the virus to be immune to the vaccine. So just like the bacteria, if you get antibiotics and if you don't use them correctly, the bacteria can mutate and able to immune. Same with viruses, able to immune from the vaccine because it's not as strong, or they just mutate, and which may cause an epidemic or an outbreak. For instance, there has been a measles vaccine in the 1990s. It has so far has been in 3 years 55,622 cases of measles reported, and 90% of those were not vaccinated. People were not vaccinated. So this is a very problematic situation. We want people to be taking their vaccines so that we won't have another outbreak of these same viruses. And that's it. My name is Drew Doling, and have a good day.
Spectacular.